All right, so for a tide problem like this, anytime that you are trying to write a sinusoidal equation to model something, you need to know those three lines, because those three lines are how we graph these things, how we get the equations and how we graph it. We got our high, we got our middle, we got our low. Based off of what we're reading right here, it says that it hits high tide at 11:36 a.m. We need 11:36 converted to a decimal time. So we're going to take the 36 minutes divided by 60. You can use your calculator. I just did it a moment ago. 36 divided by 60 is 0.6. So that means that that is 11.6 o'clock at a decimal, whatever that means. So at that time, you're at high tide, and high tide is 11 feet deep. So that tells us two things. It tells us high tide is 11 feet, and we're there at 11.6. Now, if we are starting at the top line, because that's where we're starting this graph. If we're starting at the top, the graph is going to go like that. And that is going to be a positive cosine function. Starting at the top is a positive cosine. So we got y equals something times cosine, bracket, parentheses, and then another number at the end. That time that we're starting at is 11.6 to the right, so that goes right here, x minus 11.6. That's our starting value, our phase shift. Next, we can keep reading and say, find that at 5:48 p.m. it's low tide, and you measure that at 5 feet deep. Low tide is 5 feet. That doesn't directly go anywhere into our equation. But because low tide is 5, we can now find the middle, and that does go in the equation. So middle between 11 and 5, 11 plus 5 is 16, divided by 2 is 8. That's the middle. Which means that we are shifted plus 8. Conveniently, it's lined up. That's part of our equation. Now, the other thing that that tells us is the amplitude. How much is it going above and below the midline? How much does it go up and down from 8? 3. That's our amplitude. Then we need b, which comes from the period. Period equals 2 pi over b. Period equals 2 pi over b. We are told in the final sentence that the period is 12 hours and 24 minutes. So we need that decimal. 24 divided by 60 is 0.4. So this is 12.4. The period is 12.4 hours. So we got to solve for b. Multiply b times the 12.4 and then divide by 12.4 to get b by itself. B is 2 pi divided by 12.4. Or you could reduce that because you divide by 2, top and bottom. Pi over 6.2. A little bit, couple numbers less to type into your calculator. Either way, 2 pi over 12.4 or pi over 6.2. That's your equation. We make a sketch, use that sketch to help us find everything going to the equation. Now, we use the equation to answer these last questions. Find the depth of the water. Depth of the water, that's our y value. So we're doing a y calc. When x equals these things that it tells us. 6 a.m. is x equals 6. 8 p.m. that means it's afternoon, so that means it's 12 plus 8, x equals 20. We have two different x values for our calculator. You could plug them in, or you could graph it and then plug them in. You could just straight up plug in a 6 right here, or you can graph it first. If you're going to graph it, You gotta type it in. 3 cosine pi over 6.2. If your calculator does not make fractions like this, you have two options. Quickly buy a new calculator that does, or put parentheses around your fraction. X minus 11.6, and then we should have, after all those parentheses, we should have the plus 8. So type it in. When we go to draw this, you need to set up your window. Your X values that we care about is for a full day. So X goes from 0 to 24. Those are the X values. X is time. We want a full day, 0 to 24. And then our Y values, it's the depth of the water. Could be anywhere from 0 feet deep to 11, I think was the max. So you want to go past that. Something past the 11. So I did 20. So it looks like this. If you set that up and you get a straight line, a flat line, your calculator's in the wrong setting. Is the calculator supposed to be degrees or radians for this one? Radians, because there's a pi in it. If there's a pi, you got to be in radians. So, calculators in radians, x's go from 0 to 24, y's go from numbers that at least encapture 5 through 11. So, smaller than 5, bigger than 11. All right, so we go ycalc and then type in those two answers. Gsolve, ycalc, x equals 6. That was our first one. 5.137. So let's just say 5.1. Then we do it again for x equals 20. Gsolve, ycalc, x equals 20. 6.7. Last. First time on that day, so the day is already 0 to 24, so whatever we get for the first time will be in that day. When the water is 6 feet deep, that's a y value. Y equals 6. We need the x value, so we're going to do an x calc. Or you could have done another line that said y equals 6, and then done the intersection. So, Gsolve, x calc, y equals 6. Happens at 3.74. That's supposed to be a time. 3.74 o'clock is not acceptable for a time. So we need to change that 0.74 back into minutes. So we're going to go to that 0.74. And we got to change that to minutes. So we're going to multiply it by 60. 60 minutes for 1 hour. So it's like 44. Almost 45. So that means that that is 3:44 a.m. because it's a number less than 12. There will always be a number less than 12 because it's the first time that day. It happens high tide, low tide, all that stuff happens about twice a day because it's 12 hours and 24 minutes apart. So it'll happen, there's always a morning and an afternoon time, or morning and night time.